Cleaning guys back. We've got 4 of your pistons from your Allis 210 that we built
Yes,
twice. Why are we coming back to this?
Okay, well, let's just say what we've got here for pistons. We've got 2 of the original pistons there on the right that came out of the worn out engine, and we have 2 new pistons that came out of our failed engine from after we rebuilt it. And there has been quite a bit of discussion on piston cylinder wall clearance. We do not feel that was the problem with our engine, but there's been a lot of people that seem to think that is. These old pistons are definitely made out of a different grade of aluminum than the new piston is. I believe these are actually a tin-coated piston. These do not have the tin coating on them. These are from 1970 era. This is 2020 pistons. There's been quite a bit of discussion that we should have had more piston cylinder wall clearance. Our belief is that the alloy that these 1970 pistons were made of expands more than the alloy that they're using on modern pistons. We went with the clearance recommendation of the piston manufacturer when we put this engine back together, which is considerably less clearance than some of the old service manuals say this old engine was supposed to have.
There's a lot of discrepancies in the Allis 210 manuals. They range...
I can't remember the exact numbers, but some of them are clear down there, certainly under 5 thousandths clearance. Some places you look, it says you need 7, 8, 9 thousandths piston cylinder wall clearance. So that's been one of the problems too, is finding the correct information.
We know that materials have changed over the years, especially in the last 50 years.
Yes.
We figured we have some of the pistons from 50 years ago out of your engine. We have pistons from a couple years ago out of your engine, and we have tools that we can measure and actually put some data to this, actually get a quantitative analysis of it.
Yeah.
So that's what we're going to do today. We'll find out if our assumption is right or wrong today, but first we're announcing some limited edition merch. We're collaborating with Epic Desk to bring you this custom mousepad inspired by the 4 strokes of the internal combustion engine: suck, squeeze, bang, and blow. This mousepad measures 930 by 400 millimeters, or roughly 36.5 by 15 3/4 inches, and features real artwork, not AI artwork, inspired by yours truly. The size easily fits a keyboard with enough space for a mouse to glide smoothly across, and the print quality, stitch quality, and cushion of the pad are second to none. In fact, I think I'll be ordering a second one for myself so that I can keep one at my desk and use a second as a work mat for our MC1 measuring center. That way we can keep all of our extra tools, standards, and parts safe and protected while we're working on them. Each mat is a limited edition and ships with a certificate of authenticity. They'll be available for pre-order from now until August 13th, but once that window closes, they'll never be sold again. Check out the link in the description for more information, and don't miss out on this one-time run. So our plan here, again, we have kind of what we'll call a good old piston, and then we have a scored up old piston, and we have a scored up new old piston.
Right.
And a nice looking, I mean, if you didn't tell me this had been run in an engine, especially an engine that had a catastrophic failure, I probably would never know.
Right.
The plan here, we're going to use the nice pistons to do some different measurements at different points along the piston, as well as different temperatures. And this is going to be kind of controlled, but it's also going to be kind of wishy-washy.
Yeah, I think we can get good enough results here to either prove or disprove the point we're trying to make. And we honestly don't know how this is going to come out. We
might make idiots out of ourselves.
Yeah, we might be making idiots out of ourselves here, but we wanted to see firsthand. I think we can get good enough results here to show an overall trend of whether or not these pistons expand at a similar rate to the old original pistons, and whether or not you can tighten up the clearance on the new pistons compared to the old pistons.
We're actually going to cut 2 of the pistons in half.
These scored up ones, we're going to cut those apart just to see what is inside that piston.
Is this all diesel pistons, you would say?
Yeah, most all heavy-duty pistons have an insert in the top here, so it'll support the top ring better.
Yeah. Another thing that you see in cast pistons sometimes is a steel strut that kind of goes
inside around the pin area and reaches out into the skirt area to help control expansion.
I feel like you see that more on lower quality pistons because they're not hyper-eutectic.
Right. Yeah, that's the thing you saw, your automotive side, your engines out of the 50s, 60s, 70s, they most all had a steel insert of some kind.
So we're kind of curious to see if there is any kind of steel insert. Usually you see them.
Yeah, a
if
lot
there
of
are
times you can
ones.
see where it's in there, and I suspect there is in these, but I can't see it.
Let's start with taking a couple measurements here at room temperature with our new measuring system and go from there.
Sounds good.
So this is our new QMP Racing MC1 measuring center, mainly for pistons, but really anything round. And basically this kind of takes the human error out of using a micrometer and allows us to make sure that we're being accurate and consistent. We've already set this up with a 4-inch standard, so we've got it, I guess, calibrated. Okay. So basically what we did here is we kind of rocked the piston back and forth to find the high spot there, and then adjusted the micrometer until our indicator here, this 10th dial indicator, reads right at 0. And we're getting technically 4 inches, 0.2466. Let's do the old piston at that height now. And again, this piston, obviously it's used, has some wear, but we would expect probably be similar size. And looks like we're a few tenths off there. .24605. Basically a half thousandth.
Which kind of surprises me. If those old pistons were supposed to have that much more clearance than the new ones, I would have thought that piston would have measured significantly smaller than that.
Theoretically, most manufacturers size the cylinder to the nominal size. Yeah. Clearance is built into the piston. Sometimes that's not the case on older stuff, but
yeah, generally the cylinder will be the nominal size and the clearance is built into the piston.
Right. If we pretend the liner was nominal bore size of 4,250, we would have been about 3 4/10 on the new piston, and we would be 3 9 on the old.
Yeah.
So a little bit more on the old. Which again,
is probably the wear on the piston.
Yeah, that's true. That's a good point. I don't know, 75 degrees, 72 to 75, somewhere in there.
Which about be our room temperature here.
So I'm gonna run this down. Should we go at an inch down?
Yeah, that'd
or
be
an
good.
inch up, technically.
So you actually moved a half an inch on the skirt of the piston?
Yep. 4.246, and we'll round up to 5. So we're 4.245, and we'll call it 6/10.
Is that the smallest you can make that?
Okay, boomer. Jesus.
Well, it'd be nice if I could read it.
Okay, let's go down to...
Catch another half-inch increment. Well, do a
Should I do another half?
Yeah.
Okay, so now we're 1.5. Yeah, we know there's going to be some error because I'm touching them and they're heating up.
We're not trying to do exact science here. We're just trying to get an idea, satisfy our curiosity.
Well, in the Allis Chalmers forum where you've been posting,
right?
There's another person who's apparently having some issues with a 210 rebuild.
Yeah, it sounds like a very similar problem. Had a failure right after they installed a new kit.
Okay, 42459. And kind of what sparked this is the piston clearance debate came back up over there.
Yeah, piston clearance debate came up again over their engine, but they also seemed to have some issues with the injection pump, which we felt like was the cause of our failure.
42452. And let's go on down. So now we're at 2 inches. So 2 inches is not quite perfectly in line with the pin, but it's about as far as I can adjust with the MC1. Okay, 2455, 2448, So we got our room temperature measurements, 4 different locations on the pistons.
Right.
So let's go toss them in the freezer, and then we'll go cut open the other pistons. What's for dinner?
Beef. It's what's for dinner. Sure hope Mom doesn't find out we put those pistons in the freezer.
Yeah. Well, I was thinking we should use her oven.
We could, huh? Might be better than the shop oven.
Yeah. Okay. Should we go cut some pistons open?
Let's go cut these up. I'm not sure how we're going to mount these, but we'll figure it out when we get there.
Go out to the other shop.
Look at there, eagle.
Oh, yeah. Nice. We get quite a few eagles out here.
We haven't got maybe the right saw to cut these pistons apart, but I think if we set one of them up on this side here like that with a couple of bars and a spacer that's about the same diameter on the other side.
It'll surely stay put until it doesn't.
Yeah, and we're going to have to kind of hand feed this saw through there because it's not working quite right.
That cylinder must be messed up.
Something's jacked up in that cylinder. But anyway, we'll try to hand feed it here a little bit. Worst thing can happen is trip to the emergency room. Ready?
Hope this video does good. That might be what
What really puts our video, makes it go viral, is you go into the emergency room.
Why do I have to go? I thought you were gonna go.
I'm going to stand clear. You're the one holding the camera up too close.
Yeah. I don't have glasses on either, so I've got my safety squints.
Let's put a little bit of coolant in there.
Oh, it's empty. Is it coolant or not?
It's not pumping any coolant yet.
So the coolant just won't work.
Coolant won't work. It's probably been sitting long enough, it's probably all gummed up. Yeah. Quarter of a turn now. Damn, it fell apart. There's a whole lot of aluminum. Has the, I don't know, are those inserts at the top, are they steel or cast iron?
Supposedly they're steel, but I'm not entirely sure.
But yeah, that's the only insert in there. Let's go ahead and finish cutting this into quarters.
You got a 3/4 of an inch or a half inch over here.
Yeah, look at this. There we are. I'll take that back to the shop and clean it up a little bit, but at least on the original piston, there are no steel struts of any kind in there.
I'm kind of guessing there won't be on the other, but
Yeah, I have my doubts on this one too, unless there's something right around in the bottom here. I'm amazed at how much aluminum is in the head of that piston.
yeah, it's a lot of material. So we decided we're just going to try to cut a quarter out of the...
Yeah, we're going to attempt to cut a quarter out of this piston instead of cutting it in half and then cut in half again.
Which I think will actually be easier than...
Yeah, that's
cutting
what
it
I
in
think
half.
too. Or I got a phone call here.
It's amazing how much your process improves when you have overnight to think about it.
That's right. Yeah, you just think about, there's got to be a better way of doing that.
You going to man the...
My
Hey, we have coolant today.
Well, that's why I wondered if yesterday it wasn't just the coolant had dried up.
You want that much or less or more?
I don't know, it depends how big a mess you want.
Too bad the cylinder didn't magically work better
Well,
too.
that's what I was hoping, is it fixed itself overnight, but it didn't.
Okay, you've gone past, so...
So call it?
Yeah.
That's definitely the beefiest part of that piston where we're cutting right now. Are we there? Yeah, I saw it kind of move, and I'm like, are we there yet? Yeah, there's nothing in there. Nothing in my noggin. Well, that's the new piston. This is the original piston. So those should be just kind of mirror images of each other. Actually, if anything, it looks like the new piston maybe has a little beefier in this area.
Yeah.
Other than that, they're virtually the same. I don't see a lot of difference. They both have the
Steel or cast iron top ring insert.
Yeah, top ring insert. So I don't know what to make of that.
Crown thickness looks comparatively the same. The new one has more mass kind of coming down through here.
The aftermarket replacement piston is a little heavier right here in this area, and they've added a little more aluminum on each side in here.
A little bit different right
Yeah,
here.
a little
It's
different
kind of
shape to it in this area. I would say they're virtually the same thing. I'm not.
The question is, were those changes made just to make changes, or were those changes made because they could actually improve something?
Yeah, and I can't answer that, if that's an improvement or just a design change for the sake of the way they were manufacturing it.
But it doesn't look like any kind of inserts as far as thermal
No,
control.
There's nothing in here to control the thermal expansion, with the exception of the ring groove insert that may control some expansion on the top end of that piston. But other than
may
that,
have an effect on it, but that's not the intent
Right.
of that insert.
right, that insert is there to give more support for the top compression ring.
Yep. Grab the new piston, I guess.
Okay,
It's not going to be perfect because it's going to warm up as soon as I
right.
start
I think
touching
we can
it,
get a
but-
good indication.
But we're just going to put it on here, find the high spot, and right now I've got it at a 1/2 inch, and we'll go a 1/2 inch, 1 inch, 1.5, and 2,
Okay,
just as quick as we can here
before it
before it
changes
warms up a
temperature.
ton. Is it new piston?
It's the brand new ones.
Gosh, it's cold.
Give or take 20 degrees.
Okay, 2429, 2428, 2425, 2422. Maybe go toss it in the fridge and
Yeah, let's put it back in and I'll get the other one.
2424. Drop down to 1 inch here. 2420. Let's go to 1.5. 2418. 2417. Oh, you want to toss it back in the freezer, and maybe we'll go from bottom to top. So this is the new piston at 2 inches. 2426. 2431. 2436. 2440. Got it?
Yep.
2417. Maybe call that 118, actually. 2422. 2428. 2434. 5 maybe.
4.2435.
Yeah.
So for right now, I'll go put that back
How
in
much
the
was,
freezer.
what was the
Oh,
temperature on
check
that?
temperature.
So 20 again.
Yeah.
At a 1/2 inch, 2432, 2433, 2433, 2429.
Okay, let me go get you the other piston. Okay, there's our used piston.
2428, 2424, 2422, 2421.
I told Mom preheat the oven. So I'm going to go in, put them in the oven, and we'll run them up to 300 degrees.
So you are using Mom's oven?
Yeah. She knows.
So 2563, I guess. 0.2555, 2549, 2545,
I'll take it back in and switch.
2563, 2555, 2548, 2543. You think the other one will have warmed back up by now, that we can just do our 3 experiments right in a row, or?
Let's give it just a couple minutes.
Okay. Yeah, that is awesome. It is right on 0 still. So I don't I don't think our temperature is really affecting things on the MC1, not significantly anyway. But we're going to do 3 tests hot, 3 tests cold, and 3 tests at room temperature. Then we'll take an average of the 3 and we'll compare our numbers.
Okay, so we'll start with the used piston at this point.
2552, 2542, 2536, 2531.
Okay, let's go get the other one.
2539, 2533, 2528, 2523.
Let's go cut the other one while these heat up good again. Let them get a good heat soak. Okay, one hot new piston.
2547, 2544, 2538, 2533. I don't know.
Yeah, it's just not.
The oven set at 300, so
Yeah.
we're going to guess they're somewhere around 300.
Well, they sizzle when
They sizzle when you
you
spit
spit on them. They sizzle, so they're hot.
So they're boiling temperature anyway?
They're at least boiling. So let me go get the other one. Okay, there's a used piston right out of the oven.
What did you call it?
I don't know. It wasn't piston though.
Okay, 2557, 2549, 2543, 2539. Done with them in the oven anyway.
Okay.
That time we changed just a little bit. About a tenth. That's still pretty accurate though. So we're just gonna do 2 more room temperature measurements on each piston just so we can have an average.
Yeah, just have a good average.
Okay, new piston at 1/2 inch, 2466, 2462, 2458, 2454. I'm just gonna go back bottom to top on the old piston. 2448. Does that sound right?
Sounds just like the number you had the last time around.
2452, 2456, 2461.
Those are exactly the measurements you had the last time around.
Good. Okay, let's do the new piston again. 2465. The micrometer is just fine, but this is just so much, it's just so easy to be so
Right,
precise
right.
and repeatable, if nothing else. I think it's going to be really nice to have.
No, that really takes the guesswork out of what you're doing.
2462. I mean, trying to measure at the exact height this many times in a row without this would, I mean, you could do it, but it wouldn't be near as easy. You'd be eyeballing
Yeah.
where the micrometer tip
Yeah.
was, and
And everybody has a little different feel.
should take most of the human error out of it. 2457, 2454. We'll do the old piston one more time. It is just barely kind of scored and dinged in that area. I wonder if that's kind of why it's
Getting some kind of false readings.
just kind of fighting me. 2451. I don't know. There's something goofy about that height.
Well, you came out 3/10 bigger than your prior readings, but 3/10,
Still pretty fairly accurate.
yeah, 10 times smaller than a hair.
2452.
You've gotten that reading at that position all 3 times. So literally here in the shop where things are clean but not perfectly clean, that could very easily be just a speck of dust under there that would change it by 3/10,000ths of an inch.
Well, it just kind of feels, I don't know, it just feels kind of not right.
Did you wash your hands before you touched it?
I'm ignoring you. 2456. How was that one?
Exactly the same all 3 times.
So we're wasting our time.
That's what I've been telling you, you've been doing ever since you started YouTube stuff.
2461.
You got that measurement every time.
We did 3 different measurements at 4 different positions on the piston at 3 different temperatures, kind of a cold and then room temperature, which is like it would be when we're building the engine here in the shop and taking measurements, and then kind of what we'll call a hot operating temperature. We've just averaged the new pistons and the old piston. Our initial hypothesis is that, we were kind of saying we don't need to loosen up our sleeves on our brand new kit, because theoretically the manufacturer of that kit has sized the sleeves accordingly, knowing...
Hopefully they've done their research and they know with their piston made out of their material and their sleeve, the two together make the right clearance.
And, you know, there's a combination of... Our claim was that materials have improved over the years and that has led to tolerances being a little bit tighter, not needing as much clearance. Another thing we talked about the other day was that in 50 years, just machinery has improved, and that also has had a factor in decreasing tolerances because stuff is just manufactured better nowadays.
It's manufactured better. You don't have to build as much wiggle room into it for machining errors.
Yeah. So when we compare the new piston from the coldest to the hottest, the average of all 4 points along there, it increased 11.1 thousandths from freezing cold to 300 degrees-ish. The old piston, that same thing, increased 12.3 thousandths. So the old piston the change in diameter was larger than the new piston's change in diameter by a little over 1,000. So there's definitely a difference. We were right that the alloys are different, and that was my argument. I wasn't necessarily saying that for sure that piston, you know, has better thermal characteristics than the old piston, but what I was saying is we can't necessarily go off of factory specifications for a piston that's 50 years newer. We need to go off of the manufacturer's specifications, and theoretically they sized the sleeves to have the correct amount of clearance. That being said, the argument, when you start looking at specifications, depending on where you look for this thing, you know, a couple places it says the clearance originally would have been 2.5 to 5 thousandths. And what's the other number, 5 to 9?
Yeah, something way higher than that.
And that was where the argument came in, is that we needed to open this up to the 5 to 9, you know, closer to 9 thousandths clearance, which in our opinion would have made it a sloppy loose engine.
Yeah, really sloppy loose.
And you farmed with it after we did the second rebuild.
Without any additional clearance.
The only thing we changed was the ring gap.
Yeah. Now, I wonder, from what I understand, if this new piston is a hyper-eutectic material, my understanding is they hold more heat in the top of that piston, and you have to run greater ring end gaps with that.
Okay.
And that was, I think, where my failure, you know, we had a bad injection pump, but the result of that, the first thing, next weakest link in the chain, was our end gaps came together on those rings. And that is the only change we made in that engine when we went back together, is we made sure the end gap on the rings were in the middle of spec instead of the tight side of spec, which is where they seem to be. So
from the factory, from the manufacturer.
From the manufacturer. So I'm wondering if maybe the biggest thing we need to be looking at on these is when you do have a hyper-eutectic piston that you know is going to hold more heat in the top of the piston, make sure you got plenty of ring end gap.
Yeah. But one thing we did want to look at, this is one of the original sleeves from the original engine.
Back out of the scrap. It's been laying in the scrap for the last 2 years.
Yeah. And we were just kind of trying to get an idea, like we mentioned earlier in the video, our old piston, you know, kind of the average measurement at room temperature was 4.246-ish, you know, somewhere around there. So that would give about 4 thousandths clearance if you call it the nominal 4250 bore size.
Right.
Which is different than part of the service manual says, because in the service manual it says the piston should have been smaller than that.
Right.
And if anything, at this point, that piston has already worn some.
Yes.
You know.
And that's what I think we saw here. I'm guessing when this piston was brand new, it probably measured about exactly what this one does, but it has thousandths or so worn off of it.
And that one was probably only half a thousandths bigger than this one, actually. Looking at the numbers there, between half and 1. So let's see where that's at.
Well, I've set this gauge to our nominal bore size of 4.250. like I say, dug this sleeve back out of the scrap. Luckily, I still had it laying around. Cleaned it up down here in the bottom where there should not be much wear in that sleeve. And I put it in here and measure, and I'm coming up just about exactly 4.250.
Yep.
So this sleeve with that piston right now would have what, roughly 4 thousandths clearance on it?
Just shy of 4 thousandths.
Just shy of 4 thousandths.
So I think the 2.5 to 5 thousandths spec is correct for your engine.
Yeah.
Or is the original spec for
this particular version of that engine.
in the long run, I guess we figured out we're kind of right, but maybe not as right as we thought we were.
I think we're right, but not so much that we can flaunt it.
I think we were able to prove that, yeah, the material is different, and I guess my conclusion there is that when you're working with modern parts, you need to go to the manufacturer to figure out what their recommendation is on clearances for your application.
This is no longer an Allis Chalmers manufactured piston. This is an aftermarket piston, and you better kind of look at what the aftermarket manufacturer is recommending rather than going clear back to the OEM specifications, because things have changed. There's a lot of years gone by, a lot of things have changed. Much better machining,
better materials,
everything about it. We hope has gone in a positive direction. Not only the case, but I think it has in this one.
As far as the update on the tractor, yours is still running strong when you parked it for the year? And
I don't try one of them deals. I'll go back out there, start it up, and try to start it up, it won't run. But no, it was running great when I parked it. I was real happy with that this year.
So anyway, that's it for today's video. That's your, I guess, I don't know, this is kind of a different one, but Science Week.
Yeah, Science Week on Jamsey Online.